All right, today we're doing Algebra 2, Section 2.3, and this will be the last form of a parabola that we'll be covering in this chapter. And today we're going to talk about the focus and the directrix of a parabola. So the focus is always on the inside of a parabola. Inside. And it's located at the point where if there were a point on the parabola, draw a straight line to the focus. This distance will be the same as the perpendicular drawn to this line. I should highlight that, which is called the directrix. So no matter what point on this parabola, like right here, this distance plus this perpendicular distance, those are going to be the same. All right. Keep in mind that the vertex is halfway between the directrix, this horizontal line right here, and the focus. And the directrix is always perpendicular to the line of symmetry. All right, so now let's look at the distance from the focus to the vertex and from the vertex to the directrix. And that distance is called P. All right. So when the vertex is at the origin and the parabola points up or down, this is the equation of the parabola. So you're going to want to pause right here and copy that into your notes. And then the other one you're going to want to make sure you copy down. Remember, this is when the vertex is still at the origin. We're also going to be looking at parabolas that go sideways. Now, keep in mind that these are not functions. Remember, they wouldn't pass the vertical line test. You cannot put this in your calculator because everything in the calculator has to be a function. You could solve for y and put in you could put in half the function at a time. I'll show you how to do that in class. But go ahead and write down all that information. Notice that the directrix before, when it was up or down, the equation of the line was a y equals. The directrix on these is going to be x equals, which makes perfect sense because the directrix is a vertical line. All right. Well, what happens when the vertex is not at the origin? Well, then we're going to have, I'm going to try to get all this. Hopefully you can see all that. You're going to want to write all that down. You will notice that this is in vertex form, right, with h and k. I know the vertex is at hk. I would write these down along with the pictures. Notice that this 1 over 4p is equal to a. And the way the vertex form of a quadratic function was f of x equals a times x minus h quantity squared plus k. So this time a equals 1 over 4p. All right, so you're gonna want to write all that down. And then when you're done with that, this is the one with a horizontal axis of symmetry. Sorry about that. And the axis of symmetry on these. So there's the axis of symmetry, and obviously the equation for that is y equals whatever k is. All right, and you're going to want to write that down. I think that's it. We're going to work on some of the problems dealing with these in class.